So as we were discussing, students, that whenever you finish any subject side by side, you are always getting some outcomes out of it. Okay. So as far as the lab is concerned, there are these 5 outcomes that you people will be able to achieve by the end of this semester. Okay. When you do the machine learning and data analytics lab with me using Python. Okay. So the very first course outcome is that it will help you, this subject, when you learn it with me, it will help you to develop knowledge of various learning models of data. Okay, so by learning models I means here the algorithms. Your machine knows nothing, you can only feed it the algorithms in the form of code. Okay, how you make your machine learn? Your machine only understands any language. Okay, so what we will do, we will use Python. Using Python, we will implement the algorithm, right? And that algorithm is actually responsible to teach your machine. It means if I have a rule in my mind, what is the rule in my mind? My mind has this rule that for 2200 square foot area, the price is suppose 15 lakh. And I want that my machine should learn this. So how in general with the Python, you can make this code work? So you can assign the area in A, and for area of machine one, sorry, for area of first house, you can assign a corresponding price that for area one, the price one is this one. Okay. Next, for area two, you want to predict. For area two, which is 3300, you want to predict. So area two is 3300. So you are using variables to store these values. And then now you are ready to predict that what will be the price too. Okay, so it means by learning models, I mean that there will be an algorithm and we use that algorithm, we will implement that in Python and we will help our machine to learn things. So my machine is learning, my computer is learning that area one is 2200 and its price is this. It has learned this fact. Now I am asking it to predict something. Now I am giving it area 2. So I'm giving it area 2, that is 300. And now my expectation is what will be the price of 2. So it will not give me the price directly until and unless I will feed the rules, the steps of the algorithm. These are just the initialization. I have to give it a proper algorithm. What equation it should apply so that it can predict the area of house number, sorry, the price of house number 2. So you will learn the various algorithms. Okay, with those algorithms, we will train our machine. We will help our machine to learn. Okay, and these algorithms work on models, any model, any mathematical equation you have. Okay, so you use that mathematical equation. There are linear equations. You remember when we were doing mathematics at school level? So there is a linear equation. Okay, how it works? It is B equals to mx plus c square. Okay, if this is your x-axis, this is your y-axis. So there is always a line, linear line that goes in between. And how you represent this line? You represent it with y is equals to mx plus c square. Okay, so for this value of x, this value of x, this will be the value of y. For this value of x, this will be the value of y. So are you able to predict? If you have x value, are you able to predict the value of y? Yes. If you have the second value of x, are you able to predict the value of y? Yes. How? Because of this linear model I have. So I have this linear model with me and we will use this linear model and we will create the algorithm. So this is the step number 2. It will help you to create and implement a wide variety of learning algorithms. Okay, so every algorithm has its underlying model, which means the mathematical equation, and we will implement that mathematical equation in the form of algorithm, I mean the code in Python. Okay, then we will evaluate these models and then we will apply the algorithms to real world problems. We will fetch the data from the real world. We will fetch the data maybe of IPL. You know that whenever two teams are playing IPL, there is always a prediction. You have heard to these predictions. Okay, on this pitch on which India is playing today, India has also played 2 years back. And at that time, when India played, India won the match. So there is a prediction, right? On the contrary, the other team, when played on this pitch earlier, they always lost the match. So these predictions always come. Okay. The second prediction sometimes come on this pitch. When India played earlier, the maximum target that India has set for the opposite team was 300. So I think that you have heard these predictions before the start of a match. Sometimes you have heard that this pitch is good for batting first based on the earlier data. This pitch is good for bowling first. Okay, so how they do? They have the data, they have stored the data, and they continuously evaluate this thing. Okay, it means the real world problems. I will help you to get the data of IPL, and then we will do the predictions on the basis of that. Okay, now you know that whenever the term prediction comes, okay, you know that it is not always correct. You can see that there is a weather prediction that is happening. We always check the weather. It's raining today, so we will always check what will be the weather tomorrow. So sometimes the weather, they show that tomorrow there will also be raining, and on that day when you check, what will happen, the prediction suddenly changes and it shows that it will be a sunny day. So prediction is not always 100% accurate. There are always chances of some error. Okay, so we always try to optimize our prediction. So optimize means we will try that our prediction should be best close to the accuracy. Although there are always chances of errors, but still we will try that it should be very close to accuracy. The chances of error should be minimum, although it will be there, but we will try that it should be less. Okay, so if this is the actual data that it should predict, and this is the prediction, so we want that this difference between actual thing and the prediction should be minimum. It means error should be minimum. And when the error will be zero, the error rate will be zero when your actual data will be equals to your predicted data. Whatever actual should come, it is given by your prediction. Okay, so we will try to optimize the model so that it will give you the correct prediction, which is exactly close to the accuracy. So you can see here that in the whole syllabus of your lab, we have how many programs to cover? We have total 9 programs to cover. Okay, so all these exercises, they are based on a data model. You can see that all the exercises are like this: design and evaluate a data model, design and evaluate a data model, design and evaluate data model. Okay, so each and every exercise, each and every program has an underlying data model, or you can just don't get confused. You can say that there is an algorithm that you are going to implement, and every algorithm has its name. So the very first algorithm that we are going to implement, it is the linear regression. I have given you an example that we have x-axis, we have y-axis, and this is the slope. Y is equals to mx plus c square, if you remember, right? Where m is the slope, c is the intercept. Okay, so if x is given, suppose if x is given 2, so on the basis of this line, wherever it intercepts, you can predict, okay, this is going to be the value of y. So if x is your area of the house, so you can predict that what will be the price. So if we are using linear regression, the equation that we are going to use is this one. Then there is this logistic regression. Okay, all these that we are reading now, these comes under supervised learning. Then there is KNN, then there is k-means clustering, then there is SVM, support vector machine, PCA, decision trees, random forests. Okay, and once we complete all these 8, we will compare their performance. What is the last 9th one? That we will compare the performance of all the above machine learning techniques on a similar data. We will have one data set, a single data set, suppose D1. We will apply linear regression on that data. We will apply logistic regression. We will apply all these 8 techniques, and then we will compare the performance. By performance, I mean that which algorithm is giving you the best predicted value, which is actually very close to the actual value. Okay, so This is the performance comparison. Okay, so in which the error is very less, that algorithm is best. In which the error is more, that algorithm is least good. Okay, so throughout this session, we are going to implement all these data models, or you can say all these algorithms. So in the theory class, I will tell you that what is linear regression and how it works and what is the algorithm. I will give you one sample data and we will apply it on that data. And simultaneously in the lab, we will implement it with the help of Python. So what will happen? That we will create one Excel file. You know Excel files? In Excel files, what the data is of type? The data is in the form of a column, right? It is arranged in the form of rows and columns. So we will load that Excel file into our Python program. Till now, we have only worked on the data that we give directly to the program. X is equals to this, Y is equals to this. But the data on which we are working is not the smaller data. It's the biggest data that comes in the Excel files. Sometimes the Excel file data on which we work, it has thousands or hundreds and lakhs of lines. So you can't work on each line separately. What you have to do, you have to import the entire Excel file into your program, and then you have to start the data analysis. So I will tell you how you can import or how you can fetch data from the Excel file, how you can bring that data into your program, and now if it is available in your program, how you can do the analysis of that data. We will get the insights, we will sort the data, we will arrange the data, and we will do the analysis. On the basis of that data, we come up with new values. If that data is area, we will come up with a new column that predicts the price of that area. So you can see here that this is suppose the data in the Excel. It has two columns. One is area, other one is price. Okay, so area of the first house is suppose 2600 and its corresponding price is 55. You can say 5,50,000. The area of second house is 3000. So its price is 5,65,000. And so on. Third house, its price, fourth house, its price, fifth house, and its price. So it means in the beginning, when you train your machine, when you are making your machine learn, you will give it area also, and you will give the price also. So how many values you have fed into your machine? You have fed total 5 values. Okay, machine, for this area, this was the price. For this area, this is the price. For this area, this is the price. So you will give it so many values so that your machine can learn. Okay, so your machine can understand the pattern. So what's the pattern? That as the area is increasing, the price is also increasing. 2600, it is close to 55. For 3000, it is 56 something. For 32, it is 61. For 36, so there is a pattern that we are feeding to our machine. So by feeding this data, what we are doing, we are making our machine learn. And here, sometimes we say that our machine is learning, and sometimes we say that we are training our machine. We are giving training to our machine with the data. We are giving it a training set, training data. With the help of that, now our machine is trained. Why it is trained? It is trained with this data set. And if I will give it a new value, so here it is mentioned that this is the training set that we have given it to. Now, given these home prices, what we want our machine to give us, what are our expectations? That this is the data we have fed. Our expectations are that for this value, this is the output. What will be the output for a house of 3300 square feet? What will